This video explains how to write a piecewise function from a graph to correct the most common mistakes from our Unit 1A piecewise quiz, problem number 1, before the test. As you can see, when I write a piecewise quiz, I'm going to do the f of x is equal to a French bracket. You will also notice that there are 3 line segments in this piecewise graph. The first line segment we're going to cover first, and then the second and the third. So let's go back to our first line segment here between a -4 and a -1 on our x-axis. The first thing I do when I find the equation of a line segment is that I need to find a slope, and the thing that we've kind of, for some of us, forgot is that each line segment doesn't need just a slope, it also needs a y-intercept. So this gave us a little bit of problems. This is some of our Algebra 1 and Algebra 2 skills we need to remember. The slope, again, is our change in y over our change in x. And if we look at our change in y, we're going from a 0 to a positive 3. So we're going to have a change of y is equal to 3. And then on our change in x, we're going from a -4 to a -1. So our change in x is also a 3. So we have 3 over 3, and our slope is 1. We always give you one easy equation, and then the second one will be a little bit harder. The other way to find the slope is to use the slope formula, y2 minus y1 divided by x2 minus x1. If I do this, I'm going to use the first 2 points to do this, and it doesn't matter the order, so I'm going to put in 3 minus 0, or my y coordinates, over my x coordinates. So 3 minus 0 over -1 minus a -4 is again equal to 3 over 3, and my slope is equal to a 1. We're going to talk about 2 different ways to find our y-intercept. So you can pick which way you like the best. The first one is the one we talked about in class, this is using the point slope formula, since I have a point and I have a slope. This is going to be y minus y1 is equal to m times x minus x1. I'm going to use our first point up here because it's easier. So I'm going to use y minus 0 is equal to 1, or our slope, times x minus a -4. So I'm going to get y is equal to x plus 4 once I simplify that equation. The second way to find a y-intercept is to use the substitution formula. And I know that I want this form of the equation, which is y equal mx plus b at the end. And I know that my slope is 1, and I'm going to use this point because my y is 0 and it makes it easier. And so I'm going to use this point, -1, 4. And I'm going to substitute an m, an x, and a y into this equation. So I'm going to have 0 for my y is equal to 1 for my slope times my x value, which is -4, plus b. And I'm going to solve for my b, which is my y-intercept. If I do that, I'm going to get 0 is equal to -4 plus b. I'm going to move forward to the other side to isolate my b, and I get b is equal to 4. Now I'm going to substitute my b and my slope into this equation. And I'm going to get y is equal to 1x plus my b, which is 4, or my y-intercept, and I get x plus 4. Now this gives me the same equation as I got with using the point slope method, so whichever method you prefer, y-intercept or substitution, but you need to use one of these methods so that you actually do find the y-intercept for this line. I'm going to write the equation of this line right here, y is equal to x plus 4, comma, and now I'm going to write my restricted domain, which is going to be a -4 is less than or equal to x is less than or equal to a -1. And now I've written my first line segment, and now we're going to move on to our second and our third line segment. This is my second line segment that we're going to do, so I'm going to rewrite out the first line segment, x plus 4 is a -x, is less than or equal to x is less than or equal to 1, and when I did that, that was this part of the line segment. Okay, so now we're on our second part of our line segment, and the first thing I'm going to do again is find our slope, and our slope again is equal to the change in y over the change in x. So I'm going to look at how much it's changing on the y-axis, and I look at that, and it's from a 1 to a 3, so I see that it's a 2. And then how much it's changing on the x-axis from a -1 to a 2, and I see that that's a 3. Again, my slope is negative. It's going in the negative direction, so I know I need to put a negative on that slope. To find that a little easier, I like to use the slope formula to make sure I get the positive and negative correct. And again, we're using these 2 points right here. So I'm going to look at 3 minus 1. And on the bottom, we're going to have a negative 1 minus 2. So I'm going to get a 2 over a negative 3. And so my slope again is a 2 minus over a negative 3. And now that I have found my slope, I'm going to go back and I'm going to block this off so that we can show the work for finding our y-intercept again. Now we're going to find our y-intercept again, and again it's important because this is a problem that most people missed. As you can see, I'm going to use my point-slope formula again for the first way of finding the line. Y minus y1 is equal to m times x minus x1. So I'm going to use my first set of points right here, and I am going to find that my y minus 3 is equal to my slope, which we found was a negative 2/3 x, times x minus a minus 1. I'm going to simplify inside the parentheses first. So I'm going to have that x plus 1 inside the parentheses. And now I'm going to need to distribute this negative 2/3 into the equation. So I'm going to distribute the negative 2/3 into the x and to the 1. I'm going to get a negative 2/3 minus a x minus a 2/3. Now I need to move 3 over to the other side. Now to do this, I'm going to convert the 3 because what I really want is a common denominator. So I'm going to reformat that 3 into a 9 over 3 because 9 divided by 3 is 3. And now I have a common denominator so I can add these two together. If I do that, I'm going to have y is equal to a negative 2/3 x plus 7/3, and that is my second line segment equation. As promised, though, we're also going to show you how to do that with the substitution method so that you can see which way you prefer. The substitution method is going to be where I use the form y is equal to mx plus b. I know that my slope, or my m, is a negative 2/3. And I know the x point that I want to use is that first one up there, a negative 1 and a 3. So again, I'm going to substitute the y in, which is the 3. I'm going to substitute my m, or my slope, in for m, which is a negative 2/3. And I'm going to substitute in my x, which is a negative 1 plus b. Now I need to isolate my b, so I'm going to subtract 2/3 from both sides, and I'm going to have b is equal to 3 minus 2/3. Again, I need to get a common denominator, so I'm going to change my 3 into 9 over 3, and I'm going to get 9 over 3 minus 2/3 is equal to 7/3. And as we can see from our first equation that we got, there's my negative 2/3, which is my slope, and there's the 7/3, which is my y-intercept. So there's the 7/3, and there is then the negative 2/3 for my slope. And again, that's just a simple substitution method. Whichever method you want to use, it doesn't matter, but you need to find a y-intercept. Okay, now we're going to write our second line segment out, a negative 2/3 x plus 7/3. Remember that the y equal is already taken care of with the fx, and we are going to then restrict our domain between a negative 1 and a 2, and I'm going to have a negative 1 is less than x is less than 2, and that is our second line segment. Piecewise function. Okay, now we're on our third piece of the line segment, which is this piece right here. A lot of people put that this is y equal x, but that is not true, so we're going to go through and show it. I'm again writing my first line segment out for you. That's x plus 1 between the negative 4 and 1. We're going to write out our second line segment, which is a negative 2/3 x plus 7 over 3, and that's the second part of the line segment, and that is between a negative 1 and a 2. All right, so finally we want this third line segment, which is between this 2 and the 5. And this is where we got a little wrong. There was a big error in a couple of your papers. A lot of you said that it's the line y equal x, but we know the line y equal x is this linear equation that goes like here. It's the parent function, and it has a slope of a 1 over 1. But this actually has no slope. The slope is 0 because it's a horizontal line. So if we remember a horizontal line, we know that all horizontal lines start with y equals. So this would be y is equal to, and it's constant over here, it's constant at a 1. So if we wrote this out, it would be y is equal to simply 1. Y never changes. It is always 1 between this line segment. So I'm going to take this 1 the y equals already taken care of between this. And I'm going to take this one and I'm going to write it in as my last piecewise function. My linear equation is y equal 1. And it's going to be between a 2 is less than or equal to x is less than or equal to 5. And that's my piecewise function. That is the whole thing. Okay, and that is my final piecewise function, except I forgot one thing, and that is just don't forget that that's the negative one there, because that's the line segment between a 4 and a negative 1, and I just forgot to write the negative on that one. Okay, the other two pieces, you got really well on the domain, and all of you could tell we asked you to write an interval notation, and you remembered that it's left to right, and that the domain would be between a -4 and a 5, or where this function is a continuous function between a -4 and a 5. And everybody got their range pretty well. Some of you forgot and did your domain instead of your range, but you did your range pretty well between this 0 and a 3. So remember bottom to top on that. Okay, the other piece that we need to remember, though, is decreasing and increasing intervals. And most of us got the points right, but we wrote it incorrectly. So I'm going to talk about intervals and the notation that we need to remember, because some of us got 3 points taken off because we did the wrong notation. So intervals are on the x-axis, and we write it in interval notation. So if I look here, my first, if I asked you where is the function increasing, okay, this would be how some of you wrote it where you got this wrong, and you wrote it as points or ordered pairs, and you said, well, it's increasing between a -4, 0, and then you wrote an and or something in between, and you did a -1, 3. But actually what you want to do, the correct way to write this, and I'm going to write this as correct, would simply be the interval on the x-axis, and it would be between, this function is increasing between a -4 and a -1, and that would be your answer. Now, I didn't count off too much depending on if you got the brackets right. What I was looking for is, do you know what the interval is? And that is the points on the x-axis between. So let's make sure that we write this correctly on our test so that we don't get that wrong on our test also. This concludes Unit 1A, the problems that we had. Hopefully we corrected those on our quiz. Again, we want to write a piecewise equation with y equal or f of x equal with a French bracket. Again, we want to remember our y-intercepts. We can't just write our slope down. We need to remember our y-intercepts. Almost everybody got the restricted domain right, which is good. We also want to remember that if we have a constant function where it's not going up or down, that it's not y equals x, but again, y equals 1, and that we want to write our interval notation correctly, which is really the intervals on the x-axis where something is increasing or decreasing. Okay, so if I asked you the interval where it's increasing, you would write it this way. All right, thank you very much, and good luck on your test coming up this next Wednesday and Thursday.